I'm Neil. I'm very happy to be here. By day, I work for NVidia. By night, I run the Khronos Group. And I'd like to firstly thank Francois and W3C for hosting an amazing event. And I need my clicker. So, particularly because, of course, Khronos is a separate organization to W3C, but we've always had a good working relationship. So we're super happy to be here and be part of this conversation. So who is Khronos? We're similar to W3C, we're committed to open royalty-free standards. But whereas W3C is focused obviously on web standards, Khronos' focus overlaps but is slightly different. We are a group of companies that's figuring out how to bring silicon hardware acceleration open standards to the market for domains like 3D graphics, obviously, but parallel computation, vision processing, increasingly machine learning. So there's a lot of overlap between what we do and what W3C does, which again is why I'm glad we can be here. And I think there's potential for doing more liaison and collaboration. So that's one of the things I'd like to explore during this couple of days. So I've put a summary here of just some of the standards we're doing. I'm not going to go through all of these in detail, but just to kind of highlight some of the things we're doing that we may find opportunities to work together. Of course, 3D is probably what we're best known for. We took over OpenGL from SGI. We evolved OpenGL-ES, which again supported WebGL. So WebGL is a Khronos standard. Now we have the new generation Vulkan GPU API. Of course, WebGL is not standing still. We are evolving the WebGL standard in parallel with WebGPU. So, for example, we're developing an extension for compute shaders and multi-draw batching to overcome some of the cool overhead for performance. We have some related standards. SPIR-V, it's a weird sounding name, but it's an intermediate representation increasingly getting used in tool chains like LLVM. It's an intermediate representation for parallel computation and graphics shaders. And so we're interested to see whether SPIR-V could be useful for web GPU, both for portability and perhaps even for obfuscation of shaders. We have OpenXR, which is a set of APIs for portable augmented reality and virtual reality. I'm interested to talk to Nell here the next couple of days to see, making sure that we're working closely with WebXR. We think OpenXR can save WebXR a whole bunch of work because we hope WebXR can write to just the OpenXR APIs and get a whole slew of hardware covered without having to do dozens and dozens of backends. But the reason we're here, of course, is glTF. So let's dive into glTF. So glTF was started quite a long time ago, and it came from the realization that all of the media types had their equivalent of JPEGs, a simple, widely understood, compact, easy format to transmit media assets. Everyone knows how to process a JPEG file. Back in the day, we didn't have the same thing for 3D, and that was the idea behind glTF, to make it compact, so it's easy to transmit across the network, but to make it supporting up-to-date 3D, animations, physically based rendered materials, make it independent from the runtime, so you can use the assets for whatever you're doing, a game or some other applications. And of course, making it open and extensible. It originally came around for WebGL. WebGL was the first use case that was, by definition, has to transmit assets over a network. So the first generation of glTF described the materials in GLSL shaders, because that's what WebGL does. But then glTF 2 is really where I think glTF hit its stride. And largely with the support and the input from Microsoft, we removed any WebGL dependency. So you can run it over native APIs like DirectX or Vulkan, as not just GLSL shaders for materials. So we adopted physically based rendering. And Microsoft, which is awesome. This is standard PowerPoint. This is not a video. No, this is a gLTF model running in a PowerPoint slide. And if you haven't tried it, you should. You can just drop a GLB. You can do keyframe animation between your slides. It actually works pretty awesome. So in a couple of years since we've launched gLTF 2, we had pretty astounding levels of adoption, which is good. I think it kind of confirmed that there was indeed a gap in the ecosystem that gLTF is helping to fill. So we have a team updating the logos on this slide on a daily basis. If your logo isn't here and you'd like it to be, please let us know. We'd love to add it. But over on the left, we have all the tools. It's the classic 3D tools, some of the traditionally 2D applications like Adobe tools now exporting 3D too, and they're using gLTF. For that, we have the VR and AR authoring tools, an increasing number of mobile apps capturing 3D models with your phone. They're all now exporting in gLTF, and a bunch of tools for validation and conversion. Most of the repositories up at the top are now enabling you to download the objects in their repos in gLTF. And on the right, we have all the applications and engines that are importing gLTF. So the game engines, the native game engines, the web engines, of course, including Babylon and 3.js, all of the AR and VR apps and engines are importing gLTF, and we've already seen Office, but Facebook too. You can post a gLTF object on your Facebook feed, and the 3D pictures you can capture on Facebook is using gLTF behind the scenes. And a bunch of companies. Uber just did an awesome blog post on how they're using gLTF to visualize geographic and driving data. So a lot of usage out there, which of course is good, because there's no point having an interchange format if you can't interchange it with anybody. But everyone is now beginning to import and export. If you haven't come across gLTF, it's very simple in concept. The scene or object is described in a JSON file. There's a couple of binary payloads. The geometry is a binary payload, and we currently have textures using either PNG or JPEG. We either use them as RGB textures, or we use the textures to drive either metallic roughness or specular glossiness PBR models. So it's intentionally designed to be not rocket science to process these, but because we have the binary format for the main payloads, the format is quite compact. So as we've been driving the gLTF ecosystem, there are kind of three main things that we focus on. Tools, because tools, and consistency and functionality. So to begin to persuade the tools vendors to have native import and export of gLTF, we started with Blender because it's open source, and we were able to directly go in and fund a project. So now we have native, quite high quality import and export of gLTF from Blender. And I'm glad to see that there's a bunch of other tools now following, including a lot of the key Autodesk tools and others. Consistency is really the life or death of any interchange file format. And we had painful learning lessons from Collada, which is a much larger, more complicated standard. And it suffered, though, from a real killer problem, which was some of the key tools misread the spec for Collada, and they were interpreting Collada files differently to everyone else. And that went unnoticed for long enough that a dialect formed, and then there were like two versions, and so people were trying to interchange Collada files, and it wouldn't work, and everyone goes, oh, Collada sucks. And poof, we have to avoid that problem with gLTF. So we've put a lot of effort into tools, validators. So if you're generating gLTF, there's a tool you can validate to make sure you're generating the gLTF assets correctly. There's a whole bunch of models which we encourage people to try out if they're importing gLTF. And again, Microsoft have helped us put together an asset generator which does unit tests of all of the key aspects of the spec. So if you can import everything that you can find on the Khronos website, you have a pretty good chance of being conformant to the spec. And of course, functionality. People always want more functionality, and we'll go into some of the roadmap things we're discussing because we want your feedback, but we're constantly balancing complexity of the spec versus how much functionality does the market really need. And again, this was kind of a lesson from Collada. Collada got too complicated too quickly, which led to the dialect problem. So we're constantly being very careful before we add a lot of mandatory functionality to glTF. In fact, we're still at 2.0, 2 years, and we haven't put anything else in the core, but glTF is extensible, just like OpenGL and Vulkan. So vendors can ship their own extension. They don't have to ask anyone's permission, and if they have their own customer, they can do whatever they want with the standard. But for cross-vendor extensions, we're encouraging people to bring new functionality out as an extension first. Let's find out whether it works, whether it gets adoption in the industry, and if we tick both of those boxes, then we're getting to the point where we can start bringing some of this functionality into an updated core. But we don't want to make the core spec so complicated, again, that people can't easily process it. One of the key extensions that I think is soon destined probably for core is mesh compression, because of course the transmission format size is a critical thing, and your geometry payload is often a large part of the size of the scene or the object that you're transmitting. Google have contributed their Draco mesh compression technology, so we now have a mesh compression extension using the Draco technology that can give you 20, 30 times compression on a typical geometry mesh in a scene. And there's open source software for handling that. The first thing that we're really here to get your feedback on, and I think this could be well interesting for games developers, is we have mesh compression. What about texture compression? Because of course textures are often the larger part of your asset package that you need to download for your game's title. And we live in this weird state where, even though it's the 21st century, we're still confounded by this diverse set of GPU native texture formats, and every platform seems to support a different set of GPU accelerated formats. There's PVRTC, there's ASTC. On the desktop, it's different to mobile, or the BC 1, 2, 3, 4, 5, 6, 7 texture formats. And in the native space, very often, as sure many people here know, game developers actually end up shipping multiple versions of their texture assets, which of course isn't so feasible. We're trying to transmit stuff across the network. So what we'd like is to have one compact texture format that you can transmit anywhere you want, and it will magically unpack itself into the native GPU texture format on your platform. And we think that's what we can achieve with CTTF. The spec is still being developed, but we're getting quite close. We're hoping to get this done this year. It's based on another technology contribution from a company actually here in Seattle, Binomial. They're a small company, but they're like world-leading experts on doing texture compression and transcoding. They have a technology they're calling Basis Universal, which is a image format that is about the same size as JPEG. So it's really small. But unlike JPEG, because if you receive a JPEG file and you want to get it into your GPU, you have to decode the whole file, which can be quite big, and then you have to re-encode it back into your GPU native format, and there can be a bunch of them. CTTF, using the Basis Universal format, it's cunning design, so we can easily transcode from the CTTF format into any of these GPU formats easily at low processing cost and on the fly. So you only have to unpack the parts of the textures as your application needs it. So it makes it a much less of overhead on getting the textures to flow through your processing and rendering pipeline. And we're investigating the different ways of doing streaming of textures, but that we can discuss that in more detail. So we're going to use KTX2, which is, for those of you familiar with Vulkan and OpenGL, KTX is a container format for images and textures to loading into your 3D API. KTX2 is a second generation that includes this super compression technology. So we'd love to know whether this is useful for you. And perhaps the most important thing is Binomial and Google together have worked out a deal, so there's now open source of both the encoders to create the assets and the transcoders to bring the assets into your GPU. So, and that there's C++ versions and WebAssembly versions, so you can already try this out in your web browser should you wish to. The other big thing we've been asked for is next generation physically based rendering. As I mentioned, we currently have metal roughness and specular glossy, but we've been asked for, and this is primarily coming from the 3D commerce folks. I'm actually interested to get feedback whether this is relevant to the web gaming community or not. But the 3D commerce guys, they want to have varnished tables or beautifully shiny vases that they want to look totally realistic. The automotive guys want multi-layer varnishes and leather finishes of the interiors to look photorealistic. So we're working, again, we've had an awesome technology contribution from Dassault, and we're working with all the key players that want to deploy this in their engines, and all this is being discussed on GitHub. So again, please let us know if this is useful for you. Just to wrap up, what we're finding now is that gLTF is a good kind of foundation. We're finding verticals beginning to pop up wanting to use gLTF, but add more extensions or metadata definitions around the baseline format. This is one that's coming out of Japan, VRM. They've just incorporated. It's for human avatars. What do they call them? Video, I forgot the name. They use avatars in YouTube videos rather than real human beings. It's a thing. And they want to use these in games and other applications. So all this is going to be based on gLTF2, but they're going to be adding, I think, value on top. Khronos, we've just established a 3D commerce exploratory group, which is looking to get this pipeline from product design tools, and I'm talking designing a chair or a table, through to the manufacturing process, through the retail process, through to the end user looking at that chair on their mobile phone in AR, bringing that whole process to industrial scale. So it turns out Walmart has 8 million SKUs, and they're trying to get all 8 million of those models into gLTF right now. We have 70 companies already participating. So it's kind of awesome, weird, but awesome to have Walmart wanting to join the Khronos Group. We have some other stuff in the roadmap. It's not so far advanced as the mesh compression and the PBR, but again, if any of these are really of interest to you, we'd love to know so we can prioritize more complex animation, particularly for like facial animation, for avatars, body animation, beyond what we can do now with keyframes and skinning. Level of detail and streaming, of course, is a big thing. Point clouds comes up a lot. People wanting to scan their environment and bring it into a point cloud. Draco have already offered their point cloud compression technologies. That might be something we can leverage. And I've put some resources there. Okay, thank you.